graders, we're going to go through lesson 10-4, which is a lesson called space figures, all right? Now, these are not figures from space. They are figures that take up space, okay? So, three-dimensional figures. We're going to talk about names of them. For example, a prism. What is a prism? Look at page 545. What's the definition of a prism?
It's a hexagon that basically just popped out.
Okay, it could be a hexagon.
I'm not sure.
Two lateral bases. What does that mean? Two lateral bases. What?
Lateral faces.
Does yours say faces? Mine says bases.
It says faces. Lateral faces.
Has two, parallel bases. I'm sorry.
Lateral faces.
And two lateral faces. Okay, so two lateral faces and at least two parallel bases. All right, so parallel bases means that you're going to have lines that go like this. Okay, and then on the end of the line, you will have a shape. It may be a triangle. Okay? If it's a triangle, it's called a triangular prism. If it's a square or a rectangle, then it's a rectangular prism. If it's an octagon, it's an octagonal. Not octangular. If it is a circle, it is a what? There's a specific name for this one. A cylinder. Yep. So, how do you name them? You name them according to the face, and then you say prism. Okay? Except for certain ones like cylinder. C-I-C-Y-L. All right. So you name the face. And then add the word prism. Right? So, for example, triangular prism describes this. Okay? A pyramid is another one that is a specific shape. A pyramid has a base that is a polygon. The lateral faces are triangles, so they're not rectangles, but they are triangles. Okay? So it may go like this.
3D triangle.
Yeah, a 3D triangle. All right? There's a better picture of it in your book. I can't do all the shading and things like that right now. Right? A cone has a circular base at the bottom. So this is first of all, a pyramid. So maybe a rectangular pyramid or a triangular pyramid based on the bottom base. Okay, whatever the shape is. Okay? A cone has a circular bottom, doesn't it? So that's specifically called a cone. Right? A circular base and one vertex. And then a sphere is a three-dimensional circle or a ball. Okay? Now, with that in mind, you can describe the figures. Remember, you name the base, or I'm sorry, name the face, and then call it either a prism or a pyramid or a, I guess that would be the two that are the three-dimensional, that have the parallel sides and faces, okay? The other ones are cone and cylinder. Then, the next thing you need to do is think about how you would unwrap the shape or lay it down on a flat surface. Okay? That flat surface model is called a net of the figures. A net is a flat drawing of a space figure. Okay? So think about, for example, a cylinder. What would a cylinder look like if you unwrapped it, if you laid it down flat?
Circle.
How many circles would it have?
Two.
Two circles. And wrapped in a rectangle, wouldn't it? Okay. So the rectangle would be the wrapper, like on a soup can. You would unwrap that, and then take the top, and take the bottom, and lay it out flat. Right? So this is called a net drawing. Okay? Now, with this idea, you can find the surface area of these figures. What would the surface area be? What would the surface area be called? Or how would you find it, rather? The surface area. What would you need to find the surface area? To find the area of the circle, you would need the what?
Formula.
The formula. What do you need to use the formula? The radius. So you can use the radius squared times pi. Right?
Yeah.
Now, what would this be equal to? No, think. This has to wrap, this base has to wrap around this, doesn't it? So the circumference, stop making those extra comments. That's taking away from, I'm trying to concentrate so I can teach you, and other people are trying to concentrate so they can figure out what it is they need to do. Okay? So start writing some things down and make less comments. The circumference is going to be the same as this baseline, won't it? Why?
Because the baseline wraps around that circle.
Right, the baseline wraps around that circle. Good, Michael. So either the circumference or this distance is going to be needed to find the area of the rectangle. All right, so we need the base. Or we would need the circumference. The circumference is equal to the base. Right? And then we would also need, so this would give us base times height, we would also need the height of the rectangle. Right? And then once we found the area of this circle, how many circles are there? Two of them. So we'd have to add two of those areas together. So then we'd have the area of this circle, the area of this rectangle, and the area of this circle, and we would have the surface area. All of the area that covers the cylinder. Right? Yep. How might a company need to know the area, the surface area of something? What kind of company would need to know the surface area? And why? Okay, an architect. Think about a manufacturing company.
Candles.
Yeah, like making soup cans.
Making cans, right. Any type of company that makes cans, pop cans, soup cans, they need to know how much metal to buy in order to produce the product, in order to produce the can. And then they would need to cut these circles, cut the rectangle, and put it all together. Right? Yeah. So, there's some other kinds of nets. Look at page 546. There's one that looks like this. What would this be the net drawing of? These are the faces, and these are the bases. Yep. So it's a, what class? It's a triangular prism, yep. What's this? This one is, ooh, I can't remember. How about this?
You're trying to draw
That's
today.
a triangular. So if all of these go up, a triangular, right? Stop doing it.
Prism.
Concentrate, maybe draw these out. Okay. So, these are all flat surfaces called nets. Okay? And so you kind of have to put it together in your mind, maybe fold it up, figure out what the base is, and then fold it up to figure out what it is that you're, what figure it to make. Look at your worksheet for your assignments. Name the space figure number 1. So what is the face of that, of number 1? An octagonal
Pyramid.
How many faces are there? Only one, right? So it's a octagonal pyramid. All of those points would come together. Number 2. That one has rectangular bases. So it's not a pyramid, it's a, what?
Prism.
A prism. What kind of prism? Name the faces now.
Octagon.
No.
How many sides are there in the face?
Octagon.
It's an
No.
octagonal.
Is it octagonal?
Yep, octagonal.
Okay. So it's an octagonal prism. Yep. Joey.
So which one should go in which line?
The polygons are the
Shapes.
faces, right? So it's an octagon. Or octagons and triangles, you might say. Let's see. Yeah, I guess they want you to name both types of shapes. So octagons and triangles. It's an octagon and triangles. So it's an octagonal pyramid. Number 2 is an octagon and rectangles. Octagons and rectangles. So that's an octagonal prism. Number 3. Dylan?
Oh, I thought you were going to go. It has hexagons.
Has hexagons and what shape? What is the other shape? Rectangles. So it's a rectangular. No, it's a hexagonal prism. A hexagonal prism. And the last one uses only what? Only triangles. So that's a triangular pyramid. Yep. Next page. Identifying the net drawing. Same thing, name the space figure. Then in the next section, you're going to describe the bases and name the figure. And I think that's about it. Okay? Just like you did before.